Hi Joshua. In this problem, we will see the applications of trigonometry, specifically the law of sines and functions in geometry. So here's the problem, Joshua. In triangle ABC, point D is on side BC, such that AD bisects angle A. If angle A is equal to 60 degrees and AB is equal to AD, which is also equal to 3, then find the area of ABC.
Alright, so let's drop the curtains. I already made the prefabricated figure. So as we can see here, I already listed down and 60 degrees. So from the basic of course angle bisection. So of course I'll just invent a name now because it's not given in the problem. I will make this point D. Oh, I should have used red. So in this video, I will be using red for things the things that I can't use red. Things that are the things that I put, which were not given, but I will still put it anyway in the figure. So now, angle BAD equals angle.
Oh, right. Can you write clearly? What's that? DAD?
So this must be 30. This must be 30 degrees, and this also must be 30 degrees. So in every triangle, their angles sum to 180, and this triangle, I'll just make a laser pointer so it will be easier to show where I am pointing. So this triangle BAD is an isosceles triangle because it has equal sides. So let me put this away. We can now say that let's make this angle x 180 degrees equals 30 degrees plus 2x. So if we solve that, we get x equals 75. So this is now 75 degrees. We can put this angle.
Put x. No, x is equal to 75 degrees. I thought you were going to use red.
So as much as possible, if possible, when you don't know something about there's no degrees anyway. I'll just put x degrees anyway. X degrees. So when solving a triangle, you need to, as much as possible, if possible, get either all of the sides or all of the angles. It will be easier to get things that way. So back to here. In this angle ADB or VDA, there's a supplementary angle CDA over there. So this is its supplementary angle. 180 degrees minus 75 degrees equals 105 degrees. So angle CDA equals 105 degrees.
Alright, copy this.
Since there's no equal angle anyway, I'll just put 105 degrees. There. And then for CAD, it's still 180. Oops. 180 degrees is still the sum of the triangle.
Sum of the interior angles of a triangle.
I'll just put it on the right side. That will be. Oh, I could have just moved it. Okay,
What's that? See? Can you write better?
So, we found all of the angles that we can so far. So, let's go to the next page. Here's the stroke of genius. So, this is 45 degrees.
So show them
This,
where is triangle ADC in the original figure. Okay.
So, it is this one. This one.
Yes. Triangle ADC.
Okay, so we already, I will just use black already since we already knew it. 45 degrees. This is 30 degrees. So 30 degrees. Oh, I just accidentally moved the triangle sign. Oh, okay. So, since this is 30 degrees and this is 45 degrees, they are angles of special triangles. So I can make a perpendicular altitude from D to AC. Let's call this point E. So then we have we can find this angle EDC 45 degrees and this will be 60 degrees. So we just found that ADE is 30, 60, 90. And we can also say that CDE. Oh,
It looks like an LDC. Make it curve, half circle. Yes.
CDE. Is 45, 90.
So,
So,
this right triangle.
Actually, I forgot to put something. This is important. This is 3, and this is also the same. So we know already. If we know one side of a special triangle, we can find all of the other sides of the special triangle. And most importantly, we need to find the well, yeah. So we can find DE. So for a 30, 60, 90 triangle, I'll try my best to. What if I just make a line? You'll just use the line too, so it will be much cleaner. Okay. So now this is let's assume this is a 30, 60 length triangle. So its dimensions are 2x, x, x squared root of 3. So since we know this is actually this side, it's just rotated.
Yes, you can put the vertices if you want, just to connect them. Yes.
So from here we can find that since 2x equals 3, then x is equal to 3 halves. So we have found DE. This DE.
Okay.
Triangle ADC. Oh, not just triangle ADC. It's actually the area of ADC is 1/2 DE AC from the basic 1/2 BH, 1/2 BH area.
You can put that on the side. This red or area of the triangle is 1/2 each. Area of the triangle is 1/2 each. Yes. Yes.
1/2, 3 halves, So we need to find AC. Okay. We still need one variable. So again, we can split it. This is our 36 to 90 triangle part, and this is our 44, 45 triangle. So we already did the 36, 90, and we're already there. So why don't we just do it? Since we know x is 3 halves, then we can tell that AE equals 3 square root of 3 over 2. Okay, we already know one part of AC. Well, we need to find this EC. So for EC, we already found what X is, which is DE. So for a 45, 45, 90 triangle, I'll just use the line tool again, so it will be clean. Okay. So that. So for a 45, 45, 90 triangle, this is x square root of 2. Okay, let me think. Yes, so yes, indeed, this is x square root of 2. You just use the Pythagorean theorem. So, we already know what x is here. X is indeed DE. This is D, E, C. So DE is 3 halves. So we can tell that actually, we don't need that. EC, it's kind of confusing. I'll just put it below. Ooh, funky. It stopped existing. So EC equals 3 halves too, which is also DE. So since we know EC, we already know AE. AE is 3 square root of 3 plus 2, and then we'll just add that to EC to get EC equals 3 square root of 3 over 2 plus 3 halves equals 3 plus 3 square root of 3 over 2. Maybe that's all we can do without factoring, of course. So, put 1 half is 3 halves. BC is 3 plus 3 over 3 over 8. 1 times 3, so it's 3 times 3 plus 3 squared plus 3, could that be equals 9 plus 9 square root of 3 over 8. We'll just, since it's not yet the final answer, I'm sorry, I'll just use spring green. Alright. So we don't need that. So we've in triangle ABC, we already found this area. Okay, that's already done.
Okay.
So now we just have to find ABD or ADB, which is the significantly harder part. Okay. So in fact, we can use there are a multitude of methods we can use. So actually, okay, so I can copy it. So line 2 is freaking out for some reason. I'm actually, if you don't realize it already, I'm actually moving it in the opposite direction, and Okay, I'll just, there. Good, good, good. I have to perfect it the first time so it won't freak out. Okay. Okay. Where's my legend? Okay, this is B. Can't believe I forgot my own legend. So this is
Legend
30, 75, 75. There are actually there are few references on the internet and on books that give the the specific the specific proportions of a 30, 75, 75 triangle, because it's not usually considered a special triangle, but sometimes it is. So anyway, using the law of sines. So law of sines is for any triangle. Let's say give choose different color. I'm gonna put here for any triangle A, B, C. And then this will be A, B, C, alpha, beta. It's too small. A, B, C, alpha, beta, B, C. So for any triangle ABC, following holds true. It is actually possible to prove this.
Okay, C over sine
Alright. So
gamma.
it's already kind of obvious what I'm going to do next. I'm going to find BB, because we need all three sides, and actually we already know all three angles, so that's very good. If you find all three angles in the triangle, it means you can find all of the possible things you want to find in the triangle. BD over sine 30. The law of sines indicates that it's a side over the opposite angle. So, or yes, the angle is on the denominator and its opposite side is on the numerator. Equals 3 over sine 75. Okay. So BD equals 3. So we can isolate BD. BD equals 3 sine 30 over sine 75 equals. Okay, so sine 30. Here's my calculator.
Scientific calculator. Show the new model.
It's an FX 991 units. Casio.
Yes.
So sine 30 is 1/2. So 3 times 1/2 all over what's sine 75. Sine 75 is hard to remember. Oh, it's too small. Square root of 6 plus square root of 2 over 4. Yes, okay. So this will become 3 halves. 3 halves times 4 over square root of 6 plus square root of 2. This will lead to conjugates. That's the so we want to rationalize this. Wait, I'll just think of a better way. Some 2. Oh, this will become 6. Yes, okay, I see where it's going already. We have to multiply this by a conjugate. So 6 over square root of 6 square root of 2. Since I think this will occupy a lot of space, I will have to move backwards.
To the left.
Times square root of 6 minus square root of 2. This is a conjugate. It's Especially in surds, it's extremely important to use quantities, or else you'll forever be stuck. This equals 6 square root of 6 minus 6 square root of 2 all over square root of 6 squared minus square root of 2 squared equals, oh wait, this is 6 minus 4, 4, okay, I see where it's going. So this is, I'll just already put this, I'm going to run out of space if I keep putting it. What? I just put 4 almost to it there. So this will become 4. And then we can then cancel it 3, 2, what? I didn't cancel it. 2 there. So we can now end up to the following equation, following value. Unfortunately, there's no more simplification. This is how we can go. So this is BD. This is another partial. This is another partial step, and we've already found all 3 sides of the triangle. So many might think we've already found all 3 sides. They're already tempted to use Heron's formula. So Heron's formula goes like semi-perimeter. There's another color again. This one. The semi-perimeter equals A plus B plus C. Heron's formula. Rarely it's sometimes called Hero's formula, because sometimes his name is spelled either way. A plus B plus C over 2. So it's perimeter over 2. So the area ABC, the area is square root of, I do the square root sign and then I'll just put a bar on top. Nice. Yes, it's possible actually. It's possible to do this, although it's extremely complicated. I will actually use this method at the end of the video. So first, we need it's easier. Maybe it will be better to use the easier way first. So as it turns out, for any triangle, for any triangle, this looks like a hyperbolic triangle or something. Oh, it looks like a spherical triangle now. I'll just use the line tool. And then another dot is appeared. Really? Okay, there. A, B, C. Let this be alpha. This will be B and C. Okay, as it turns out, for any triangle ABC, this equals 1/2 BC sine A sine alpha. It might be, you might realize this looks like the 1/2 BH formula. Where's that? Yeah, here. It just so happens to be the 1/2 BH.
When
it so happens to be 1/2 BH. Because of other reasons, but when the triangle is right, this will become B, and this will, maybe this is more appropriate for the other side to be the B. Oh. Weird.
it's too high. Let's use the other page, the next page. We want to be able to write here. Just correlate this one first.
So
when alpha is what?
when alpha is 90, so happens to be 90 degrees, or in other words, this is a right triangle. Yes, the area is indeed 1/2 BH.
Why? Sine
Because
alpha.
sine 90 is 1.
Oh, okay.
So now we can. So we actually, without even knowing this 75 degrees over here, we already know this is 3, 3, 30. So we just need two sides and include angle. So we can now conclude ABB equals 1/2 3 sine 30. So I'll just put another appended figure. Oh, that figure. Oh, it's the other way around. Okay. Oh, sine 30 again is 1/2. 1/2, 1/2, 9 equals 9/4. So this is one way of getting it. There's another way of getting it. I'll just use
That's the area of the triangle ABD.
another solution. So this time, oh, I don't have enough room. Do I have enough room? Yes, I have enough room.
You can use the next page if you want.
Okay, so Megalo, the line, the zoom is really acting up. There, the correct line, it's the correct line size. What's happening? I don't know what's happening. Oh, yeah, sure, this is.
You can use the next page if it's too small. You might not be able to write well. No, the vertices are inverted.
No, there's no more space. I'll just use the next page. So another way of finding it. This is there, perfect.
So you're doing now another solution, another way of solving this one.
So again we have this 30. Anything familiar? 30, 60, 90 triangle again. So we'll just make a approximate it. It's not to scale. Not to scale. Not to scale. Not to scale. Where will I put it? Not to scale. So now we have created a 90-degree angle. So this will therefore become 60 degrees. Okay, so we already know this to become 3. This other angles, this other side is also 3. Let's put it far away. So let's call this side G. Maybe I'll use F later, or I can just use F. Maybe I'll just use G anyway. So again in a 30, 60, 90 triangle. Oh, it's 2x. X squared to 3. So again, 3 is 2x. So therefore x is 3/2. What is x? That's BG. So this is BG. And in fact, if you flip this around, you can see this can be the edge of the triangle. The edge of the triangle, and this will be the B of the triangle, which is also 3. So, since we already know that, A, B, D, the area of 1/2, 3/2, 3 equals 9/4.
Nice.
And then there is one
This
more.
is a
There's
short-
one more easy compared to the hero's formula. One more easy way to computing BD about computing BD.
You can use the next
To
page.
actually to
Anyway.
computing area of ABD, and that is using the ABD's straightforward altitude, not just any special altitude. So let's make another figure. Figures. It looks kind of oblique or something. And it's wrong. This there. This looks better. Still pointing down. Anyway, let's just leave it like that. This what I mean by straightforward.
Perhaps you can
Altitude.
label that as what solution number or letter.
This like solution 3.
Usually. So just to
The stamp.
use solution.
Okay, so we're back at 3. It is okay. So whenever for any isosceles triangle with an altitude, these angles are always equal. That's because of the SAS. So since angle BAD equals 30, I can put 15. Okay, I have enough room. It's 15. And then this again is 75. There are again very few, but there exist some literature and internet sources that give the dimensions, yes, of the 15, 75, 90 triangle, as it's sometimes referred as another special triangle, although it's technically not. So there, I have a use for F. Maybe sine law would be good. Okay. Sine log in 4 angle FAB
Is that CS? C.
LS.
LS.
Now this time I was really writing L.
Okay.
I should put this figure on the. Oh, I took the. Over here. Maybe. Here. Okay. So. 3.
What does LS stand for your
Law of
viewers?
sines.
Law of sines.
Which is just one.
Applied to triangle
One.
FAD.
4. So FB over sine 15. Oh, we did not use sine 15 earlier yet, so you can isolate FT 3 times sine 15. What is sine 15 exactly? This is sine 15 plus sine, which is So then we can conclude.
Can you fix your
FD.
5? It looks like sine IS. Yes.
Okay,
So
so
not bad.
FD is 3 square root of 6 minus 3 square root of 2 over 4. This looks like sine 75, I think. For sine 75 from... Yes, it looks very similar. Wait, is this it? Oh, FD is... Yes. That's it. Okay. Oh, it's over 2. So... again, from back to this red figure, since because of the SAS, we can prove FAD is the same as BAFs, are congruent to BAF, so we can just say BF is congruent to FD. So we can calculate BD again just by multiplying FD by 2. BD equals 2FD equals oh wait, I was actually looking for the wrong thing. I'm very sorry. Wait. I was actually supposed to look for AF. Okay. Actually we already knew what BD was earlier. I think we should look for AF instead of searching for BD redundantly.
So BT is, you're right there. You know the value already.
BD equals 3 square root of 6 minus 3 square root of 2. This was our spring green thing. Okay, so for sine 75, we already know what sine 75 is. Sine 75 AF. Wait, I should put it here. That little space is worth nothing. 3 times sine 75 equals 2. Does look like a mess. Sine 75 is... I already put it. But what's sine 75? Sine 75. Easy. I just have to change to the... Oh! As it turns out, sine 75 is sine 15's complement.
Therefore, if it's the complement of sine 15,
It's not just the complement, it's also the conjugate of sine 15. Yep, okay, so AF is this. So now we can again find what the area is by using the 1/2 mesh. Was 1/2 square root of 6 plus 3 square root of 2 over 4. And again times, let's put here, do I have enough space? Yes, I do have enough space. Let's do it. Here. Yes, enough. Oh! What happened? Oh, it changed the highlighter. 3 square root of 6 minus 3 square root of 2 over 4, and then somehow it happened. And as I was saying, actually, also over 4, the numerators are conjugates. 1 over 16. I'll just put 1 over 16 in the very bottom. 16 squared minus squared 2 squared. Oh, what happened? Wrong. Maybe I should continue here, or I'll just continue here.
yes. scientific calculator.
54.
Trigonometry.
54
The scientific
minus
calculator is very handy.
extremely handy.
Yes.
What should we simplify is just 9 fourths.
Can you fix that? S4? So,
What's the other use?
no more. Just write it. Just better. Yes.
Yes, 9 fourths again.
Nice.
So now, so I've been slapping it around now.
What are the solutions? Can you compare the
It's 9
other?
fourths, 9 fourths, 9
So
fourths.
9/4. So this is your first or what?
This is the solution one.
Okay. Then the solution 2 is
2,
okay.
3, 4. So this is the final solution to find what area ABD is. And it is the long dreaded Herod formula. Okay.
So the Heroes formula. Can you write the Heroes formula first for your viewers?
So here's first Hero's formula. Hero's formula is ABC equals S minus A S minus B
Careful with the mic.
S minus C, and then I'll just put the radical as needed, and then it looks ugly. There. Okay, so we already know what BD is. I'll just append BD. BD equals 3 square root of 6 minus 3 square root of 2, and then I already forgot which was that denominator 2.
Over 2 is
Okay, so it's over 2. So just calculating S is already not really hard, but it looks complicated. So just calculating S. So we can integrate these here. This for a general triangle.
Is that the one you're looking for?
No, but this is the overall triangle
No,
for
just
any.
it might be confusing for your viewers.
Then I have to change all of this.
Yes, just change that.
What do I need to change? AB, AD, BD. AD, AB. CD, AB, equals. So this will be integrated into so the 3 will go up top, and then it will become 6 plus 6 plus 3 square root of 6 minus 3 square root of 2. And then this denominator will go down there. It will stack down until turn to 4.
What happened to the
Just
square root?
Okay, so now we have found S, but we need to simplify first.
What if you, instead of writing general triangle, right there, what formula are you using for that solution? use red instead, so it doesn't interfere with your. Okay.
So then we can simplify this. Actually, was it really necessary to put the 6 6?
What happened to the square root?
What happened to square root? Oh, I'm just calculating s first.
Yes, okay. So a lot. In this case, using the Heron's formula.
It's a lot more complicated.
It's a lot more
Extremely complicated. Not just
Yes.
a lot more complicated. So this is probably as simple as we can get. Okay, time to the going to the Heron's formula, which will involve multiple square roots, nested square roots. Oh, is it really this big? Maybe. So
ABD. You have to put ABD. They might think it's still the S.
ABD, where's the S? ABD equals
Yes.
3 plus 3 square root of 6 minus 3 square root of 2 over 4.
It's
Times,
really
times.
complicated.
Oh, so actually this is, since AB is already 3, so I need to point this out already. 3, so we won't have to go through a more complicated process. Since this is S minus 3 and S minus 3, I must simplify this already to avoid having to go the long way. It will take a long time. So it must be, I'll just make it this simple. So since there's already a 3 here, there's apparently a 3. And then I subtract 3. So S minus 3 is just simply 3 square root of 6 minus 3 square root of 2 over 4. Okay. So it's not actually, it's not as big as I thought. Good. It's only this big. I forgot something important. This is squared.
Yes.
Okay. And then the final term, is actually bigger than expected.
Make it longer if you need to. You can use the other
So
succeeding
this
pages.
is just x. And then we're going to subtract BD with this is BD. This BD. So minus. Ooh, it's still in highlighter. Why? So indeed, this is actually longer. Even longer than I expected, actually.
Yeah.
Oh no. Oh wait. So what could we possibly do right now?
There's a parenthesis there.
Where?
3 plus none, sorry.
So
My eyes fooled me.
maybe the first thing we should simplify is this. Maybe. 3 square root of 6 minus 3 square root of... we're going to use possibly one more page to use.
Yes. Do what you must. Don't squeeze them all here.
Yeah.
I don't think you will be able to simplify that in just another one step.
I expect this should be shorter than earlier. I really expect this should be shorter than earlier. I'm going to integrate the 3 into the fraction. Because if you're dealing with fractions, just keep all of them under over one denominator. It's better. And then for some reason it reverted to highlighter once again.
No problem. looks
Wait.
scary complicated.
This is not just scary. This literally is so scary. Okay. I'm already going to expand this one because if I don't expand this, I will have to expand that sooner or later. 3 square root of 2. Oh, it's longer than expected. Oh no.
Yeah.
Oh, this is just one. This is just one fraction, and it's already almost done. It's going. I'm going to go until the
Yes,
page
I
ends.
think so. The whole page, you need the whole page.
Okay, over 16. And then what if we simplify this one? What will happen if we simplify this one? This integrates here. This becomes. We just multiply this by 2. So this becomes 6 and this becomes 6. Yeah, see. And then this one will also be integrated.
Yeah, so you're going to have them under one common denominator.
So one extreme denominator. I'm assuming it will go the entire page. I hope it doesn't. 12 minus 6. Oh, square root of 6. I have to put a parenthesis. Minus 6 square root of 2.
Oh no.
Yes. Oh no, indeed. Oh no, indeed.
Okay.
This will be extremely big. Oh, wait. I actually assume this will already get down to size.
So are you able to combine anything? Use red to signify the terms of which you can combine.
I can combine. I don't want to combine something at the moment.
Okay.
Oh wait. What if we already remove the parentheses so it will be easier? We can remove them anyway. Oh, okay, so we can see the like terms. Anyway, I'll still continue on the other page. So I'll just point out these are the ones we should.
Yes.
These are the ones we should combine.
Yep.
Okay, so the one will become negative 3 square root of 6 and then the other will become 3 square root of 2. This doesn't seem right. I already prepared another page because I am fearing it will reach until the other page. If it doesn't, then that's good.
All over 4.
What? Okay, I'll just already start simplifying this. 3 square root of 6 squared. 54. 54. Square root of 3 plus 18. I'll already start combining since 54 plus 54 plus 18. 54 plus 18 is 72. 72. Alright, so this will become 72. And then, what is this over? This over 16. 16. Can we factor anything out? Can we factor anything out? We can factor out 4.
Later, just write first for those your factors. And then
Right.
the third parentheses, third pair of parentheses.
Something looks familiar.
Yes.
So indeed, yes, you're looking at it right. It looks extremely fact, even the denominator is the same. So you can see these are extremely related. So we treat the denominators apart because we treat the denominators apart. But if you can see the numerator, we can do this like a minus b. A.
Can write on the left
Wait,
side.
I'll just put this. I'll
On
just
the
put
right
this
side.
later. So a minus b plus c. It looks like that. It looks like that.
Yes.
And there's a formula for that. It's already given in most textbooks.
You can use right.
Yes. A minus b. Oh, wrong. Oh, wait. I forgot I can fix minus easily. Minus a minus b plus c. And this is equal to a squared minus b squared plus what? Plus 2bc minus c squared. Okay. Let's prepare. So we can factor this one. We can factor this one out. We can factor this one. Yes, it won't reach the last page. Yes, what a relief.
This
I
is
realized.
mental gymnastics, Josh.
This is not just mental gymnastics. This is the entire Olympics.
Mental Olympics.
Again, I will factor later. But I will already start factor. Oh, it's even longer. No. I suspect it must be as long. As long. My bet is as long. Yes, it will reach. Yes, okay, we found it. Yes! Perfect. So we can now do some stuff. So if we simplify this one, 144 minus 54 plus
This is
36 square root of 3.
using the scientific calculator in this case is really very handy because you can use the memory. There's just so many functions which are very useful.
So 144 minus 54 minus 18, 72. 72 plus 36 square root of 3. Oh, they're multiple roots. They're nested, except they're multiplied. Looking good. So we can now factor out 4 again, and then we will see something very interesting. Something very, very interesting indeed. So this will become over 4, and the other one will become over 4. This is 18 minus 9 square root of 3. And in fact, this is 18 plus 9 square root of 3.
Oh, what
So
are
they are conjugates.
Yes.
Okay, so now that means the square roots will be completely eradicated.
Yes.
And then from there we can just simply say this will become this not yet over.
Yes.
The Olympics is just the final trumpets are just blaring. That's it. We're not yet done.
And what is
We're on
that?
our
You
way.
write it here. What's the area of what?
Dun, dun. Dun, dun. A, B, D.
Yes.
So this is equal to square root of 81 over 16 equals 9/4. Yeah, so our hero's formula is the wait. We're not yet done done with the main problem. The main problem was to find ABC. Oh no. So we're back to mental gymnastics. Or mental Olympics at least. So we still have to, we already found ABD. But wait, since we already found ABD, what is that?
And
what
then
is that
you
name?
found also a
And we already found ADC. Wait,
So-
I'll just highlight this little uniform.
Yes.
So now. Oh no. Which we already found to be 9/4 to Mars. What was that we got earlier? I forgot already. This is so far back. Wait, is this it? Is this ABC? Moment of truth.
Yeah. Go back.
Is this
to the first
this
page.
ADC?
Check.
Oh, this is ADC. Wait, I should remove this mark. It makes it confusing. Why? Okay, so 9 plus 9 square root of 3 over 8. 9 plus 9 square root of 3 over 8.
9 plus 9 square root of 3 over 9
Plus 9 over 8. Anyway, I made a mistake already. You know what? I hate it already. It's ruining the moment. Okay. So 18 plus 9 is 27 plus 9 square root of 3 over 8. Is this all we can get?
Yes.
And this is all we can get, actually. So, what does this mean?
That's the area of
This is ABC. We found ABC. Alright, so this is it. We have reached the end of the road of the mental Olympics.
yes, that was cool.
Alright.
That was nice.
So, I hope you learned possibly a lot from this video. So, thanks for watching.
Thanks for watching.
Bye!
Good job, son.